Today's talk is entitled Anti-Gravity and the Death of Newtonian Physics. And so what we have is an experiment here. We have 4 neodymium magnets, a bolt, a nut and a washer. And what I'm creating is 2 objects, one of 4 neodymium magnets with repelling magnetic fields. You can see them here in the picture. They're not attached to each other and they're pushing actually against each other. And the second set of magnets for the experiment are attracting, and here they are without being bound or the nut tightened up, so they're attracting to each other. And these will be used to drop down a couple of different sized tubes, some in copper and one in plastic, and to test the ideas of gravity and how it functions. There will be a second video with more detailed findings. So what we have is a wooden construction. It's doweled, there's no screws in it, copper piping of various different diameters, and plastic pipe. These are all set to 400 millimeters. So what we're going to do is just show that these are not magnetic in any way. We're touching the neodymium magnets with the copper tube, and it's not attaching to it. Obviously now the magnets have been bolted together, and these will represent the magnets that we're going to drop down these tubes to record the speed. So what we're going to show now is the magnetic field. What you will see is a little split there occurred. These are the repelling magnets, and you will see a difference in the way that the magnet attracts the iron filings. In fact, what you have is 2 poles. You have 2 norths and 2 souths, or 2 areas of magnetism. The field looks pretty scattered. It's not forming the normal circular field that you would expect, but it's an interesting effect. Of course, it drags less material with it as you tap it around. If you have a look at the attracting magnet, which will be shown shortly, you will see a far greater mass of magnetic material attaching to it. You have the classic shape, the poles standing up, and obviously there are magnetic loops forming which aren't strong enough to bring all that magnetic material into the dome shape that you will see on certain illustrations of magnetic fields. So we're trying to test out whether this magnetic effect has any difference in the rate of descent. Here I'm just pointing out the magnetic uplift or poles or whatever you would to call them. So this is the experiment. We have the attracting magnets drop down the copper tube, and the framework is as I described. So the descent starts, and we give the time on the video. That is the end of the descent, and we will then repeat this. So the magnet falls 400 millimeters in 0.67 of a second. That we've cut these to give us the timings of them. We then repeat it with repelling magnets, and what we find is there is a difference of 27 seconds. So the attracting magnets fall slower. So now we have the plastic tube, and we wouldn't expect any effect or any differential between these two under the laws of gravity or Newtonian physics. So the attracting magnets fall 400 millimeters in 30 seconds. the repelling magnets, which are dropped down the tube, fall 10% slower at 0.3 seconds, slower or faster, or difference. The large copper tubes, we drop in the attracting magnets down them, and that fall rate is the same as the plastic tube. So obviously there's no interference with the copper tube, and the repelling magnets are dropped again, and we have that 10% differential. So something is going on between the difference between attracting. So now what we have is we've decided to put the magnetic fields horizontally, and there is again a differential. So these poles now are acting on the copper tubing, and so we have some differences there, and the repelling magnets again are dropped, and so there's a 13-second differential between the repelling and attracting magnets. So what I'd like to do now is just to discuss the findings. So in picture A, we have the attracting magnets, and we're dropped down the copper tube, and the descent is the slowest of all the experiments at 0.67 of a second. The repelling magnets are dropped down the same tube, and they fall 27 seconds faster. So there's an anomaly, there's a difference already. Now this, obviously there is a known effect, I think it's called magnetic dampening, and you could put this down to the magnetic dampening or the copper tube experiment until you come to the plastic pipe. The attracting magnets fall 400 millimeters in 30 seconds, and we've done other experiments which is more or less a free fall state, no interference with the plastic tube at all. So in picture C, it falls at 30 seconds for 400 millimeters, and the picture D, which is next to it, the repelling magnets, it falls 10% faster. So the repelling magnets fall quicker than the attracting magnets, and that is an interesting observation which shouldn't occur under the laws of gravity unless there's another force. So in picture E, we do the same with the copper tube. This is a bigger copper tube, and it actually falls at the same speed as a plastic pipe, and so there is no interference with the magnetic field in the copper. It's falling at the same rate as the plastic tubing. The repelling magnets fall at the same speed of 10% faster, or 10% differential. So then when we go to experiment G, or picture G, the magnets are dropped horizontally, and again the interference occurs with the copper piping. The repelling magnets fall 13 seconds faster, as they fall faster in every single experiment. So that is the observation of these things, and what we need to do is talk about the copper tube. Is a type of magnetic dampening, strong magnets, neodymium, which are the ones that I'm using, and they interact with the copper tube, which up until these experiments were run, they never thought that they would work. So what we have now is I put together a video just to show the speed in which these magnets fall down the copper tube. Now these are slowed by half, and under Newton's laws of motion, The force equals the mass and acceleration. So we know that the mass is the same. The force of gravity should be the same. And so in the copper plastic tube and the large copper tube, we still have a differential. And so further investigation is required. Obviously, while putting this video together, there was something that was particularly funny. And Newton was one of the last magicians. I'm not sure that in schools we teach Isaac Newton's occult studies. But Isaac Newton was one of the Rosicrucians. The Rosicrucians believed in special ability to contact spirits and talk with spirits, which I would suggest is a tremendous folly. I'm not suggesting that people can't do that. What I'm suggesting is they shouldn't. And part of this Rosicrucian symbols and links with Freemasonry is the all-seeing eye. And whilst we were putting this video together, I wanted to protect the camera underneath to film the drop-in magnet, so we put a perspex sheet and dropped the magnet down the tube, so it actually didn't hit the lens of the camera. Obviously these things are expensive, so I asked my son to line up the video camera, and I was roaring laughing at the all-seeing eye down the tunnel, or the one that they use in the Freemasons in the triangle on the dollar. And so it was pretty humorous. And also, when he pulled his eye away, we had the light at the end of the tunnel that people have with the near-death experience. So anyway, I will continue the next experiment, and it'll show if it can be reproduced that some of Newton's laws need to be revised. Thank you very much.